So we are all welcome to the group of this webinar. So yesterday it was a bit intense. We are rushing, hoping to do as much as we can, hoping to do some visualization. But uh, I think let's just revise what we do, a brief revision, and then carry on by like 9:30, and stop. So today we'll just build on what we did yesterday, did a bit of revision, and then see how much we can cover. We actually have too much, but we don't need to finish everything because in just 2 days we cannot address everything, and this is uh, just an introductory class. We are trying to introduce the concept, not necessarily build the expertise at this stage. So this is this is not so this is the one slide. So if you remember, we introduced what R is, and then the R Studio. We said there are two separate softwares. You download both at the same time, and then if you're opening, you open the R Studio, which the R will open in the console. Say the R Studio has four windows, which we call panes. We have the script, we have the source window where we have the script, we have the console, we have the environment, and we have the 540 pages. But we said that these windows are dynamic, you can edit everything. Not necessarily to have the same windows for everybody because you can change everything. You can change the color of the font, the background color, everything. Everything is modifiable. So we also talk about packages. We said packages are toolboxes in R that contain functions, data set, and other information. We said they are the building blocks that expand the capability of R from a normal basic statistical software to an advanced, very strong, one of the most used statistical software in the world. So we have a lot of packages, newer packages are being developed. Most of these packages are stored on CRAN. Others that are not certified by CRAN are in GitHub. So depending on which we are using. So to get a package, you need internet connection and you use the function install the packages. And then in parentheses and double quotation, you write the name of the package and you install it only once in the lifetime of your R. You don't need to install again unless if you deleted your R and then reinstall it again. And if you are going to use the package, you use the library function. Well, in the file pane and package um pane, there is a place where you can just click any of the packages, but then we said we are doing open science here, so everything has to be reproducible. So we have to show how we did everything. So just write library, that's the name, and write the name of the package in parentheses. You don't need double quotation at this stage. We said you can always get help in R using the help function, or just put question mark at the beginning of the name of the function or anything you want help. And then there is a build help page in R that has a lot of information that will help you solve most of your problems. We said R, just like other programming language, is building block. Its initial use is just as a calculator, just like computer was created to do basic arithmetics and now advanced to do complex stuff up to like quantum computing like that. So R also says origin is building blocks start with this basic arithmetic calculation, which include addition, multiplication, division, and exponential calculation. Can also do um we can create data object in R. So we can create the data object in R, and the most common data objects are the scalars, vectors. We have characters, numerics, lists, data frame, logics, and a lot of others. So if you create a data object, you give it a name, that name can be anything, and you save it using the assignment operator. We will say we have forward and backward assignment operators, and they virtually look the same. It's just that it's how you write it, just like you write Arabic from the right hand side to the left, and then you write English from the left to the right, so just like the same thing. And then to print the output of what you have, the object you have saved in your environment, use the print function, or you just call the name of the object directly, it will appear in your console. if you are using a console. If you are using R Markdown or Kotlin like we are doing now, it will appear below the code chunk. So the most important, we said, data object in R is the vector, because almost everything is a vector, while some argue they are scalars. But the vector, we have different type of vector. It can be character vector, numeric vector, logic vector, a lot of vectors. And you check the class of the type of the data object using the function class. So you just write class, then in parentheses, you write the name of the object, and then it will show you whether it is a numeric, double, integer, or character, or logic, or factor, or any of the data objects in R. So we create vector using the concatenation function, which is small letter c with parentheses, and then we put the list of objects inside and separated by a comma. After we create the vector, we can, if it is numeric vector, we'll be able to do further calculation. You can add, you can subtract, you can multiply, you can divide a vector, and it will go across, just like if we are doing we are looping or we are iterating. We can do some basic descriptive statistics in R using the base R functions, which include mean, median, min, max, standard deviation. Or if you want everything at the same place, we can use a summary function. Just summary in parentheses, write the name of the vector. Well, this will work even if it's a numeric or character vector. For numeric vector, it will give you the first and the third quartile, the minimum and the maximum reading, the mean and the median. Standard deviation has to calculate it separately. If it's a character vector, it will just do this is a character vector and it tell you the length. That's the number of the counts inside of the object inside the vector. That's all it does. So we said there are different ways to create the vectors. There are different ways to do everything in R. So just like the approach you use, because all about data analysis, just analytic thinking. Everybody has his own ways of approaching a problem, just like a problem solving thing. So you have a problem, you want to solve it. Everybody has his own approach. No one is better than another. You just get this approach and perfect it and continue using it. So we can use the sequence function or the repeat functions to create the vector. For the sequence vector, we said it has 3 arguments, from, to, by. So from this number to this number by that number, that's the space or the intervals between the numbers. For example, if we say sequence 1, then comma 100 is we say it's just like we are saying sequence from 1 to 10 or from 1 to 100. If we said from 0 to 100 by 25, so we said 0 to 100 and the interval of 25, because 25 is the interval. We can also do the repeat function, which is very, very important. The repeat function is used for a lot of complex analysis like simulation and other things, but here you can repeat this character yes up to 3 times, or a number, or even a vector up to the number of times you can specify. We said we can select the values inside a vector using the square bracket. We say just it works like the filter function in dplyr. We'll talk about dplyr just in a few minutes. So you can use this square bracket to select observations that select rows, and it can be in a form of like criteria-based selection. You put a criteria and it will do that for you. This is very important. You can use it to subset data, though there is a function called subset that we use to subset data. Then we said also you can convert character vector into a factor, which we use if it has a logical order. It's a categorical variable, something that can be categorized. For example, gender can be categorized into male and female. Education can be categorized into various level, primary, secondary, tertiary. Then maybe tribe can be categorized. So we can follow the long way, create the vector, then use the factor function to combine the factor, or use a nested function. That means you use the repeat function, for example, here to create the vectors, and then you repeat them to the specified number, and then you use the factor function all in the same line of code, which is called nested function, and you have it. So this is a one way. There's another way you can pipe everything and then get it. And I'm sure somebody might think of a better way to do it. So we said in a normal clinical data, there are a lot of missing values, especially if the data is much. If it's just like 1 to 100, then we are not expecting actually missing value in data that is that small, because it shows how it's too small to make a mistake actually. But then if there is a mistake, we have to accept it, because usually as a data analyst, you just have to work with what you have. So if there is a missing value in a vector, then we cannot do any arithmetic calculation like calculating mean, median, or standard deviation. Have to control for that missing value. So there are a lot of ways. The most basic one is to use the na.rm is equals to, which we use inside at the point of the calculation. So you are not removing it, you are just keeping at that point you are doing that calculation. And if we do that, we'll be able to do some arithmetic calculations. We said we can check for missing values using the is.na function, or we can use the complete.cases and use the exclamation mark, which means not. So say not complete the cases, just as it's written here. Or we can find the position of the missing value by using the which function in combination with the is.na. And then we had a clinic a real life scenario. We said that a clinician was doing a research which involved many sites across the country, and they are mainly taking information about participant age, blood pressure, weight, height, and other variables. So we said the aim here, what we wanted to achieve is to load the data into R, find what's wrong with the data, it is clean, it has some problem, and then clean the data so that we'll be able to do some analysis. So that's the real life scenario. So we just imagine that that clinician have sent us the data and then we start working. So the first thing we do is to load the packages that we are going to use. That's usually what we first do during data analysis. Well, it's not possible to just sit down and think of all the packages you might want to use, because, as I said, um, data analysis is like problem solving. So just like you might try one method and it will not work very good for you, and then you remember that I can use that package or that function, that package, and you just quickly scroll up, go to that place where you load your packages, then add that package, and then scroll down and use the function you want. After that, we load our data into R. We said we can use the disr function, read.csv, or the dplyr package function, which is inside tidybar, which is read_csv. We said we mentioned a bit of differences between them, but the most important one is that read_csv load data faster, especially if you are using big data compared to read.csv. And then we said we start with doing exploratory analysis, learn about the data, understand your data. Like you have, for you to do very good analysis, you need to know every part of the data. That's why you need to take your time, understand data, because once you understand data, 50% of your work is done, because you know everything inside, then it's easier to manipulate the data and get the desired result and or make sense of the data. So you can check first the dimension of the data, how many rows, how many columns you have, and then using the dim function, or you can check individually using the n row or the n column function, or you can just take a glimpse at the data using the glimpse function. This glimpse is also in dplyr, so you need to load your tidyverse package. And then we said you can use the head function to see the first 6 observations, or you can specify the number of observations using the n argument, or you can use the tail function. I didn't write the tail here. Just like tail. So tail, and then you get the last 6, and then you can use the n also to specify the number of observations you want to see. The names function here will give you the names of the variable. This is very important because we usually copy and paste actually. We don't like typing much. Copying and pasting help us minimize the mistake, because we said R is very case sensitive. If you miss a letter, or maybe you put a small letter inside of capital letter, then it will not work. For example, if I want the name of the variables, I just call the names function. It will give me all the names, and I'll copy and paste the ones I want to use, and then I'll just remove the code from that place. So as you see, the name of the packages are displayed here, and this is not the standard way to write the name of package in R. R will not accept any special character. It will not accept space. Any space or special character should be replaced by an underscore, and then most of everything in R is written in lowercase. A few things are have combination of lowercase and uppercase. To get the full summary of the data, we use the scheme function, which is in the scheme R package. Just set scheme, it will give you full summary of the data. It's also important to just take a general look how the data is generally constituted. Then you can look at individual variables using the count function to see the number of, especially for categorical variables, like that's the character variables. And so it show you the inconsistencies on how each of the entries are entered in that variable. At this point, I should remind us that in data analysis, we don't use a coded data. If they are coded, then you have to record them again. And then I forget to add how to record the data, but we still use the factor function. Since I mentioned that, let me just write it here. For example, if this is sex, and then sex is in the data frame row, right? So you write row, you use the dollar sign. Yesterday I mentioned that the dollar sign are used to select variables, that's columns. So you dollar sign sex, then you put your assignment operator. If you can remember, the shortcut for the assignment operator is alt hyphen, so assignment operator. Then copy this one and paste it here. Factor. So why are we doing that? Because we are writing everything. Then we write the labels. That's how they are coded in R. And usually, because there's more than one code, it's something like this. Then with the labels, that's the interpretation of the codes. So this is like basic the syntax. So we are not creating anything new because we are selecting the same variable in the data set, and then we are writing it. So one might say it's not making sense. Yeah, it's not like that, but then R code is written from inside out. So if you say that you are telling R, the first thing I will do is everything inside the parentheses and everything inside this factor function. So it will take the information first from the variable, that's the coded information, and you write the code which is coded 1, 2, and 3, 0, 1, 2, and 3, and then you tell R that 0 is M, 2, 1 is F, and then 3 is other. You have other, which we don't have, right? So it's telling, so you first take the coded information and then process it, and then you write the same variable. Well, that's what it's doing. It's usually not advisable to the write because it means that you are losing the information. If you made a mistake, then you have to go and load the data again and then run all your calls again and then right. But then sometimes it's better than creating a new data object because we said earlier, well, I said yesterday that it's choking our space because R run on our RAM. So if you don't have much RAM in the computer, even if you have much RAM where you create too many data objects, then it will choke your RAM. Then it will slow your analysis, especially if you are running some complex iteration. So this is how you record the variables. And then now we have this one, but this data that we simulated earlier is not coded. So that's why we have them like this. So we assume that it's just a data entry error. Maybe it's an open-ended question that everybody is asked to write his gender. You know, people write differently. Some will write just F, some will write female with capital letter, some will write female or uppercase, some will write female or lowercase. Everything will be haphazard. That's why one of the practices we use in data collection, especially we, the data managers, is when we are designing data quality tool, we use validations. For example, in KRCT, we use REDCap. So REDCap is very good for data collection, and you validate the field in such a way that nobody will put anything you don't like. So data will be much cleaner, but still there is some point where people can make an error. So that's why data cleaning is very important in data analysis. We do the same for just of the variable, just observing how the data is entered and then the counts. And then at the end, you look for duplicate. The duplicate here is get this function is the get duplicate and is in the janitor package. That package is very, very good for data cleaning, and we use it a lot. This data cleaning, I'm emphasizing on it because it's very important. A friend, I can remember last time asked me, how do I clean data in app? I said it's a bit tricky, but it's easy. Some prepared, even some R users, I know some R users that prepared to do their data cleaning in Excel and then go back to R and do the analysis. But anyway, you use is personal preferences anyways. Okay. So you get the duplicate, it shows that we have some one or two duplicates. We know that later on we have to remove this duplicate so you can work with duplicate data. And then you check for values that are outliers. Outliers, they are values that are outside the normal distribution of the data. For example, we have age of -3 and 900, and then we have weight of 750. This is clearly an outlier. And then outliers are usually for a numeric variable, not categorical variable. For categorical variable, we check the spelling, whether it's spelled right or wrong. That's what we check. And then we can we can do the filter. This we talked about the filter function later, which is in the deploy package. We can put some criteria. These are all criteria using the O. O, we said they are Boolean, just like if you're familiar with PubMed, you use a lot of Booleans when if you want to expand your search, you use the O. If you want to narrow it, you use the and. So we find these people that have an outliers, we find the ID using this criteria. So getting the ID will make it easier to remove them or replace them with something else because we usually replace with something else. You can replace with NA, you can replace with something that you know that at least to make you aware that this is an outlier and then exclude it from your analysis. So the first thing is to fix the errors. So to fix the error, we start by standardizing the variables, and because that's the most important thing, because everything you call the name of the variable to do everything. So we use this function from Genito package, which is clean underscore names. Just as simple as that. Name of the data set, which is row, we pipe it into the function and we run it, and then we call it, then we have clean data variables. This is very nice and then very easy to do and very, very helpful. Then you can rename the variables one by one if you want, or maybe if you, I don't know, if you just want to do it, personal preferences, you don't want to use the genital package, you can just do it one by one and rename everything. Well, it will take longer and it will take much of your time, but then still, it's personal preferences is also doable like that. Or maybe you have a specific name to give it, because if you use this clean.names, it will just use it, it will just like change the names in a specific way that computer has been programmed. But if you want a personal naming, then you have to rename it individually using the name function. So you can remove all empty columns. This is also in the genital package. So we remember some of the columns we saw earlier, they are empty. So there's no point returning them in the analysis. So remove empty columns. So you use the function remove empty and you specify that you want empty columns, not rows. And then you can look for the unique variables for these columns here. So we use this fixing function to find things that are similar to each other. So let me run this one so that you can see. I've run the data. Okay, I've not run the data. It should work now. I've not loaded the packages. Where is the adjustment here? So it shows that though we have 300 observations that are unique, no one is similar to each other because why? We have we have we have duplicates because our data we have, if you remember, we checked the distribution data, there are 302. So we have two duplicates and then 300 that are unique. So we'll need to control for those duplicates later. So we can use this mutate function in dplyr to create a new variable, or in this case, write the variables. So what we are doing here is, remember the gender variable, it contains a lot of spellings, errors. Some are written in small letters, some in capital letters. So use this string to lowercase to convert everything into lowercase. This function string to lowercase is in string R function, which is in tidyverse. So tidyverse has saved out a lot of effort loading each package differently because it has like 8 packages that all loaded in the same time. Then we use this in function to search for information that are inside a block vector. Just saying that we search for sex that have this variable number. So in the vector sex, we search for those that have M small letter and male small letter, and then convert everything into this. So that's the in function. We use it a lot. It's just written similar to the pi function, but then it's not pi because you have in and it's called in. Everything else we convert it to NA. This is NA underscore character. It means that after you finish, because this thing is rewriting the sex variable because we use the same name. If we said sex1, then we are creating a new variable, but we are writing the previous variable. So we are just like cleaning the sex variable. So the first we convert everything in the sex variable, all observations inside there, we converted them to lowercase. And then we use this case queen. Case when is just like it else, but then the good thing about case when is that it takes more than one criteria, while the if else take only two. The if criteria and the else criteria. It's just like if I if I log into this lecture, then I will watch the lecture. Else, that means if I did not log in, then I'll go back and do my assignment. So that's the two criteria that if else will take. But case when it will take infinite number of criteria, just be writing them 1, 2, 3, 4. That's why you use case when here, though if that will also work besides sex in this factor that have similar things, convert them to this thing is called tilde, is like approximates, right? So it's called tilde in R. And then we said true. This true is an argument in the case when it will work even if you not put the true. But then here, because we want any other thing to be converted to NA, which is this NA underscore read. If we said true is equal to NA without using this any underscore character underscore, it will just create a character variable called NA. But this one is telling us that NA means not available, just like we are deleting everything to be space. But in our data sets, we can't have space, so we put NA. So at the end, we can count, and then we have exactly clean names, female and female, that is well written. This is exactly as we specify it here, and then the rest we compare them to NA, which is this saying NA is equals 10 variables that are NA. Then we did something, we do the same thing for the rest using this string to title. Just like, remember in Microsoft Word, we have a place where you can change into uppercase, lowercase. We said capitalize the first word or sentence case. So just like this, like similar to that, because this is a way to deal with strings, because strings are series of characters. So this string to title is just like the title case. So we are converting it into title case, which is the capital. It will just use the title case. So we are converting this region and the smoker name to a title case. and then it will be like this. This is the title case, and then the other one is the title case. So we have them here, and then this one also we have them here, which is just like capitalize the first letter. Yes, no, yes, no, because that's the only issue here we have. And then the next is to remove spaces, which is we use also this string underscore trim. The trim will remove space before and after a character. That's why we want to remove any space that is before and after a character, and then we use this string underscore replace to replace this underscore that is between the drag with a space. So it's saying that in this word you replace this hyphen with a space, and if you load it, it will be something like this. So the space between comma has been removed, and then this hyphen has been replaced with a space, but R does not like hyphens. So you have put space or underscore. So this is the standard way of writing. So we continue fixing the problems. We finish with the categorical. Now we go to the continuous. The continuous, we have age. We said we have some age that are outliers, age less than 0, age more than almost 1,000. So we need to remove those. They are outliers, clearly. You cannot put them in analysis because they will skew our data significantly. So we mutate. This mutate function is used to create a new variable, but here we are using it to rewrite the previous variable. Anytime you use the mutate, but you write the same name of the variable you already have in your data set, then you are not creating any new variable. You are writing the previous variable. It has its pros and cons. Writing and creating has each has pros and cons, but some will prefer to create new variable. At least you have your previous variable preserved, while some will prefer to write a new variable. It depends, and also it depends on the sensitivity of the variable. It's a variable that you feel that I need to keep it preserved, then you just create a new one. But it's a variable that you need that like age, you can easily write it, which is not easy. So at this point, I want to bring our attention to something. Whenever you are doing data analysis, whenever you have a data, just do a backup of the data, or maybe keep the create some other folder where you have a copy of the data. In case you miss the data, or maybe you spoil the data, or you do something that the data got corrupted, you have a backup of data that you can easily go and get and then do your analysis again. As we know that now data is money, and some data they are very sensitive. I've worked with data that have to sign a non-disclosure agreement for them to give me the data. So it's very, very sensitive working with some big data and data that people spend a lot of money collecting. You know, some sad grant can be up to 10 million. So you can't imagine somebody spending 10 million. And then the only output you have is that data. Then you come and misplace the data or corrupt the data. That's very, very bad. So here we are writing and we're using the if else. You remember if else I just talked about? So this is the two criteria. So we said if age is less than 0 or age is more than 120, convert it to NA. So you see all those outliers we converted to NA. Else, this is the else you keep the age as it is. So this is the if else function. This is what it means. If age is less than 0, it can be as two a single argument or criteria or two criteria. Here there are two, and we use the O. The O, they are this logic operators, so they expand the search. If you use and, maybe I need to explain this O. So the O will work like this. If, for example, I have a condition, and that condition can either be true or false, right? So the condition can be true or it can be false. So let me just go. So if I said age, I want all age to be less than 0 or or more than 120. Less than 0 or more than 120, right? So let's give an example of age So if we have 56, so 56 is it less than 0? No. So this one is X. But okay, just let me put something here out. So 56 is less than 0? No. 56 is more than 120? No. Then the output, what will be the output? Okay, we cannot talk. So this criteria is less than 0, not more than 120, and then 56 is less than 0. It's not less than 0, it's not 120. So this will not be included. So it will not be included. But what we have, if we have, let's say -1. -1 is less than 0? Yes. Is more than 120? No. Because put no. But it should be included in the outputs of the analysis. Even though that is only satisfy one of the criteria because we are using O. So if we use 121, it's less than 0, no. It's more than 120, yes. It will also still be included in the output. So you see, even if you are using O, if it satisfies only one of the criteria, it will be included in the output. But if we are using AND, then it has to satisfy both the criteria before it will be included in the output of the result. That's why we said O will expand the result, while AND will narrow the result, because you have two criteria that need to be satisfied simultaneously before it is included in the output of the result. So we have this if else, if it is less than 0 and more than 120, then put it to be NA. If else, that's in this criteria not satisfied, then keep the age as it is. It's the same for the weight here. Weight that is more than 300 NA, it is else is this criteria not satisfied, then keep the weight as it is. So if you run that one, you convert all those outlier age and weight into NA. So you use also here the summarize function. This summarize function is in dplyr package. So the summarize function will take everything and summarize it into a single output, which is a table. But then if you put one or two variable, it will give you all three those variables. Because why we say summarize? Because this is the whole data set. D here is the whole data set, and we are piping it into that function. But the only output we are getting is only these three things that we are specified. So that's why it's called the summarize function. And take everything and summarize it into a single output, or the number of specified output. So what we are doing here, we are checking the mean of the age, and we are calling it youngest. So just like we are creating a new name. And we're taking the max, we are calling it oldest, and we're taking the weights, max weight, and we're calling the heaviest. Note that we are not creating any object here because we don't have assignment operator here. So, and we are not writing the data because we don't have assignment operator. In the case of the example above here, we are writing the data. So we are replacing these variables. We are creating the NA inside the data. So I'm writing those variables inside the data set. But in this case here, we are not writing anything because we have not put any assignment operator. So unless we have assignment operator, we are not creating, we are not writing, we are just running the analysis as it is. That means the output is not stored anywhere. You are just visualizing the output, you are not storing the output anywhere. If I run this one, I have the result. So I have the result here. We see we have this. This is because I have not run the previous example above. If I've run it earlier, then we have converted everything into NA. So we see the youngest now is 24, or let's say 88, and then the heaviest is 1. Well, it's not necessary that I must create this. I can use only the summary function, and then it give me the summary of the variables that I want, which is just this and this one. So it's just how we want, because you just say summary Actually, let me just show you. Summary, because you have to use the dollar sign here. The data set is called D, and then use the dollar sign. It will give you the variable type and in the data set. The good thing about that is this prediction. At least once you put the dollar sign, all the variables will come out and give you everything: the mean, median, the standard. The median, the quantiles, and then the maximum, and then the end is also. So now we look at the dates because we have a variable for dates, right? So if I run the data, you see you have one variable for date. So we are cleaning everything. So this is the date of enrollment. So we are touching almost every variable in the data set. So for that date, we use a package also in tidyverse. Just good in our tidyverse. Everything by loading one package. Well, tidyverse is a meta package. Then you have run like 8 other packages. So in that package, we have a package called Lubridate. So it's used to deal with dates in R. There are other packages, but that's the most commonly used because it's in tidyverse. So now we are writing. Why we say we are writing? Because we have our assignment operator, and the name of the data set is the name we are assigning the output inside. So that means we are writing everything. And we use the mutate function, and we said date a role. So we are writing this variable date a role because we already have the name of the variable in our data set. I'll use this function dym. This is the function in the Lubridate package. And as it's written, DYM, it means day, month, year. It means that we are standardizing the dates to be in the format of day, month, year, right? So even so, if you run, let me run this one again here. So as it is now, you see the dates variable is written as character, right? Which is very wrong because this is a date. So we want R to recognize it as a date. That's why we are changing the type of the data from character to date. And we use this function in Lubridate to tell R that this is a date and the date is arranged as day, month, year. So there are a bunch of similar functions in Lubridate. So if you date, some dates are not arranged as day, month, year. So they can be arranged as month, day, year. And this MDY I wrote is a function in Lubridate. So just write MDY and then put the name of your variable. If it is YDM, and just to think about the good thing is they make it very flexible. YDM is year, day, month. MYD, just like that. So they make it very, very flexible. So just like look at how your date is arranged, and then there is that function Lubridate. So you don't even need to even go and be searching Lubridate or information on Lubridate and to see whether that function exists. It does exist. Just look at how the data is structured and then the format. So if I run this thing here, let me put this one to asterisk. Okay, so if I run this one, it means I've written the data, the variable to be dates. So if I call it again, you see that it is labeled as date now, not a character, which is better. And you see, instead of separated by a forward slash, just like above here, now it is separated by hyphen. And then even though the function we use say day, month, year, and here they are written as year, month, day, it doesn't matter because if we are doing analysis, this is how it will present day, month, year. So that's the format we have set. But it's written like this because this is the standard way of writing dates in R. No, not even in R. That's the standard mathematical way of writing date. Year, from month, and day. So let's move further. So this is the whole analysis data cleaning we did in a single chunk of code. So if you want to just write everything in a single chunk of code, then you can do it. So but this one is after you have seen your data, you have become better in analysis, then you can just write it. I will not even run it. And then at the end, after you finish your data analysis and data cleaning, sorry, you want to write the new clean data, right? So you can use also the bizarre function or the function in the dplyr package. So this is write_CSV, which is a dplyr package function, because this is CSV. If it's Excel, there's function for Excel also. But this file is a CSV file, and then we are writing it as the CSV. So how does it work? So here we write the function, and then in parentheses, we write the name of the data we have created. In this case, we have this. Okay, this one is said HPV. So because this one is the one we created here. So this is the name of data in your environment, the ones that you've cleaned in R, and then the name you want it to be saved inside your Explorer, that's inside your computer, in the file, and you're working directly on your project in your computer. And then it ends with the data type CSV. This will work only for CSV because we use function write_CSV. We have for Excel, we have for tab separated, we have a lot. So this is like what we call exporting data, writing data. So once you write this one, then in your Explorer, you have the new clean data set that you'll be able to share with your colleagues, or maybe run further analysis on the data, which we'll do now. We want to do further analysis on the data. So let me quickly move to day 2. So this is day 2. And then we want to okay, let me run this one again. So this is like the analysis on the data cleaning we did in a single chunk of code here. So it should do everything, and give us the glimpse of the data. Oh, everything has been removed. So now let me introduce the dplyr package. So the dplyr package is, so we said, is arguably the most used package in R, and it's inside the Tidyverse package. So you can either load Tidyverse, which have the dplyr and 6 other packages inside, or you can just load dplyr individual. How do you load dplyr individually? Just use the library function, library, it will predict, then you write your dplyr. If you have it installed also, it will predict. Yeah, it's predicting dplyr. Then control enter, you have your dplyr package activated, so you can use it. So one of the most, five of the most important function, well, before that, I think the most important thing in dplyr package is the pipe operator, right? The piping, which is this /, and greater than, or percentage greater than, sorry, percentage greater than percentage, the pipe operator. You can remember yesterday I was explaining the pipe operator. So it's like writing a single line of code with multiple packages at the same time. The input of the data will enter into a pipe, just like a water pipe that has an entry and an exit, one entry, one exit. So the output will enter the input data, sorry, the data will enter through the entry. Then the post package or the post code or the post function will process the data, and then will give an output. And then the output will serve as the input of the next function to also do what it's asked to do, and then give an output. And then the output will be an input of the next package or function, and then it will process and then give the final result. So that's the piping. It makes writing code easier because you remember when we are doing the factor, we have to combine 6 to factor. We have to write like 2 lines of code. If you piping, you just pipe everything and then get the result easier. So piping is very, very important. So here we have other functions that are very important in dplyr. We have the filter function, very, very important. We have the select function, which is this one, filter, select. And then we have the summarize function, also very, very important. And then we have mutate. And then we have group by. Where is group by? Is somewhere below. Then we have group by, and then we have others like arrange, and I think that's all. So, but then the most important ones are the filter, select, mutate, summarize, I think this four are the most important. Then you can add group by then arrange, because even in the previous example, you see how we have been using the filter, the summarize function. Some Okay, let's look at the filter. So filter is used to select observations. That's rows. So it's used to filter from rows, select observation from rows. For example, if we said we want all participants with age more than 60 years. You see, the criteria is the 60 years, and the 60 years is an observation in the row. But um, we are focusing only in a single column, which is age, right? So, but then the output, if you run the output, it gives us everything because it is filtering between rows, not between the columns. So even though we said age more than 60, and then age is a column on itself, and we said more than 60, it will just filter and give us everything. All other variables, that's columns, will also be in the input. So we're not specifying a single variable. We are just filtering between rows. That's why we say filter used to filter between rows, just like the square bracket we said earlier. So while the select function, so if you see here, we are piping, this is the name of the data set, HBP, that's hypertensive data. Then we put the pipe operator here. Let me use the ones we are used to, and then filter. So if we're writing this code from the scratch, it'd be like HBP, HBP, then pipe operator. We have a shortcut Control Shift M to give you pipe operator, but let me just write it pipe. Then to make it aesthetic, I'll just click down one level down, explanation. Then I'll write my filter. Then I would say the age more than 60. And then I run, it's the same thing. So why didn't I make everything in the same line? You can write everything in the same line at work. Just like I'm trying to make everything look better. As we said, if you're writing, write it better, because if I'm using more than one function, then the line will be longer, 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 which is not good. It's better to be down, 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 down. And the good thing with R will take care of all this indentation, unlike Python, but this indentation can make your life also miserable. So then we have the select function. The select function is used to select variables. If you say variables, we mean columns, columns of data, just like this. Patient IDs, date of enrollment, age, sex, region, weight, height, CM, everything. So how do we use it? Just similar to the filter function. We give the data set. If you notice here, there's no assignment operator, right? So it means we are not writing, we are not creating anything. We're just doing the analysis to see the output. We are not, if we check our environment, there will be nothing new created, no new data object will be created. So our data, we pipe it into the select function, and then the first argument. So, okay, let me just mention something. Each function in R have a syntax of how it's written. So this is filter. You write, this is X, that's the data set, and then you write the condition. Let's say this is the condition. So this initially is how we write the filter function. Filter, the name of the data set, and then the condition, right? And let's try its filter HBP, and then let me copy this condition. But I have to put the $sign. Which, oh, okay. This is not good. So this is filter you take age more than 50. So this one, there's no hyphen or anything. So we are just selecting the row filter function. But the pipe here, because of the pipe, we remove the name of the data set because we have already piped the data set. So it's a single input. The data set is already inside the pipe. So this is same for the select function. It's also similar. Select X, that's the name of the data set, and then the variables you want to select. So because we are piping here, then we don't need to put the name of the data set. So we pipe the data set and we ask it to select only 4 variables. And these variables are age, sex, systolic blood pressure, and patient ID. One might say these are not in double quotation. Yes, they are not in double quotation because they are name of the variables, not characters. So they are not name of the variables. So that's a bit different. But if your variable name is not written in a standard way, then I will automatically put a single quotation. It will put it between a single quotation, and if you remove that quotation, it will not work. That's telling you that the name of the variable is not standardized. So if I run this one, then I select only these 4 variables, which are the patient ID, age, sex, and systolic blood pressure. So another important function is the arrange function. It just used to arrange numeric variable in descending or ascending order. So here we take the data set, we pipe it into the arrange function, and then we use this function again, descending order, it's telling it that we want the output in descending order. And then we pipe it into the head function. Remember what the head function do? It will give us the first 6 observations only. So run this one. I'll have only the first 6, and they will be in descending order. And then the descending order will be based on this variable systolic blood pressure. If you set age, when you remove systolic blood pressure and put age, then the descending order will be based on the variable you specified age. If I had not put the descent, maybe I just put age, then what's the opposite of descending order? Descending order, then it will give me it in ascending order. So that's how it's worked. Then another one is summarize. We have seen the summarize, right? We said that text overturn and summarize it in the single output, and that output is a table. So even though our data might be a data frame, the output will be a single table. So for example, we are saying here summarize means it's solid blood pressure. So this is the name of the output we are giving it. We use our equals to, and then we are calculating the output mean of systolic blood pressure. This is the name of the variable. We have the variable somewhere in our data set. And then because it's a numeric variable and we know that there might be NA, then we control for NA using the argument NA.rm is equals to. So I run this one to give me the name of the name we specified for the output here, and then it gives us the result of our mean. And if you look at here, it said a table because it's assumed that this is a table with a single row and a single column. So that's how summarize works. We usually use summarize in combination with group by. So I'll show you the group by data. But the main issue of using a filter, the pipe operator, is to use more than one function at the same time. So if I'm using pipe without with less than one function, with maybe less than 2 functions, then maybe you kind of even opt not to use. But then the use of pipe operator is addictive. So once you start using it, then almost everything, every code chunk will be piping. So for example, here we have how many functions we have. This one, filter 1, select 2, arrange 3, and then head 4. You see all 4 functions. So I will assume that this code here is a single line of code inside a pipe. So we take the data set, HBP, we pipe it into the first function filter. And what are we filtering? We put the condition, right? We said sex is equal to female. Why are we using double equals to? This is a way in R to tell it that it wants this to look exactly as it is specified here. What do I mean? It should, if it is written in capital letter, I put 10 will be in capital letter. If it is written in small letter, it should look exactly like word by word, character by character, exactly as it is. That's why we have the unique, the double double equals to sign. Well, this double equals, you can combine it with exclamation mark, sometimes not equals to, but this is, we are not in that stage yet. So then we pipe. So our data set enter into the pipe, meet the first function, which is filter, and then satisfy this condition. And then the output, we pipe the output into the next package function, which is a select. So we know that this filter will go to all the variables in the data set. So we filter, but we output will contain all the variables in the data set. That's all the columns. And we want two columns only. So we use a select function to select only these two columns, age and solid.credo. And then the output will pipe into another function, arrange. So we want the age to be arranged in descending order. So we have a nested function, this descend, telling it that this age should be in descending order and it should be arranged. And then the output, we pipe it in this function called head. Head will give us the first 6 observations in the data frame on the data set. To run it, you only have the two variables you specified, and then only for females. So this is not specified female, but we know that because of this function, they are only females. Because of the filter function, they are only females. And then we are only taking the first five, six, sorry, first 6 observations. Then how do we add new variables into our existing data set? We use the mutate function. So previously we used the mutate function to write the variables, right? So now we are using the mutate function to create new variables, which is the main use of the mutate function, is to create new variables, but then you can also use to write. So how do we do that? First, if you are creating new variables, then you have to use the assignment operator. That means you write this, the name of your data set, assignment operator, name of your data set. But one might ask, why am I writing, why am I like duplicating the name of the data set? Well, because the code is read from here, then to here, then everything will be saved here again. So you have your data set, you are piping it, and then it will be processed, and then will be saved again with the same name of your data set. So that means you are writing your data set. So let's look at this code. We are trying to calculate BMI. So remember yesterday we did similar calculation for BMI, but then this one is a bit more complex because we are putting some nested functions. So first, to calculate BMI, we use the formula. We know the formula, which is weight in kg over height in meter squared. So we keep that in mind. Then we write the equation just as we mentioned. So, well, we know that we are creating a new variable. We use the mutate function in the player. So we write mutate. What is the name of the variable we want? Name of the new variable will be BMI. And then we use the equals to sign. And then we write the equation. So forget about this round function. First, we have this equation. Weight, we have this variable weight divided by weight in cm over 100. That means we are converting this weight to a meter, right? Because that would what we did yesterday, convert the weight to a meter. And then because we said height in meter square, so we put the square root. So we use this sign to put the square root. So this is for the BMI calculation. While because we have this round function, which is asking it to round it into a certain number of decimal place. So everything here, we will round into 1 decimal place. So this is different. Then this is the decimal place. So look at the parentheses. We have each function will come which is on parentheses. We have the round, which is parentheses. So now we have to close it at the end. So we close the first parenthesis. And we have mutation, which is parentheses. So we have to close it at the end here. Also, we close the mutation parentheses. This is very important because if I miss one parenthesis, it will show me an X here because there's an error. And it's very easy to miss parentheses if you are writing a long chunk of code. Uh, that's one of the disadvantages of pipes, because if you are piping a lot of functions and you are using nested functions, then at the end you have to close each and every one parenthesis. If not, you have an error. So if I run this one here, it will run, but I will not have an output. But so nothing will show. Even in my environment, the only thing will change is that the number of variables will change from, I forget the number, to the new number we have. But if I want to have an output, I can put everything here inside parentheses. So everything, I'll put it inside parentheses. So you see from the beginning to the end, I add another parenthesis. So now at the end, I have 3 parentheses, and then I have one here. If I run this one again, it will run, it will save, and then it will give you an output. So it's just like you are printing and saving at the same time. Sometimes we do this if you just want, so you don't want to use the print function, because as we said that if you want to view the output, you have to either call the name of the data object or use the print function. But another way, you just put everything in parentheses, and then it will save and print at the same time. Oh, we have we don't usually use that one. So okay, now that we create the new variable BMI, we want to select the variable BMI from the data set. So we have it here, variable BMI that we just created. Why are we having any in some places? Well, one of two observations in that row are missing, so definitely we have any. So let's go down. Yeah, the group. Okay, the cut function. So this cut function, well, it's one of the functions that we now is becoming outdated. I don't know. Yeah, people hardly use it because of the just when function and the APIs function. Because the same thing you do with the cut function, you can do it easily with the case when function or with the APIs function if you only have two conditions satisfied. So the cut function is used to like group numeric variable. For example, if you have age as a continuous variable and you want to make age a categorical variable, that's create an age group. So you have your age and then you want to create age group of maybe infant less than 1 year, then under 5, then toddlers, then adolescents, something like that. So you can use the cut function to do that. So the cut function is very, very easy. Let me write the syntax for the cut function. This is cut, and to come with parentheses, right? X, the data set. So you put the name of the data set or name of the variable you want. Then you have break. Then you put parentheses because you have to put something inside. And then you have labels. So this basic how to write the cut function. And an example is given here, but there are other arguments inside the cut function because uh, it's one of the functions that sometimes we use and sometimes we don't use because of the effects. The thing with the case when and the else function is that, as I said earlier, they are sometimes addictive. Are we still on? They are sometimes addictive.
Yes.
Once you start using them, then you ignore these functions like cut and everything. So here we are using the cut function. And if you look deep, you see that we are trying to create age group from the age variables. And the age group will be less than 40, 40 to 45, 55 to 60, and then 60 plus, or 70 plus, sorry. So we are using pipe and we are writing. That means we are writing our new data set. why do I say we are writing? Because we have our assignment operator, and then it shows that we're saving everything into the data set again. So another thing, so the first thing is we have data set, we pipe it into the mutate function, and then from the mutate function, we are using the cut function inside. So we are using nested function. So the mutate is saying that we are creating a new variable called age group, and what will be saved inside age group. Then we use the cut function to specify the observation that will be saved inside the out group. And the cut function, it follows the syntax as I read above. First is the name of the dataset. Here is the name of the variable because we have already piped the dataset. And then next is the break. So the break here defines the intervals. At which intervals do I have my breaks? So we have 0 to 40. So, but then it's not 0 to 40, it's 0 to 40. There's something I've not specified here. The default, by default here, we have something what we call right. Right is equals to, no, not right, John. Right is equals to. This is the default. Right is equals to. This is default for the cut function. And what does that mean? It means that the intervals are closed at the right. So the right is closed. You understand that? So it means that it is from 0 to less than 40. This one is a bit tricky to explain. So it's from 0 to less than 40. And the way we write it in R is using parentheses and square bracket at the same time. So square bracket. So the square bracket is showing the closing. So this is right close. Well, if we said right is equals to false, that means that it is open, it is closed at the beginning, square bracket at the beginning, and then open at the end. I don't want to explain this thing because it will end up confusing us. But the default is right is closed, so it means from 0, any value less than 0, even if it's minus 1 million, to the value less than 40, maybe 39.99999, because it is closed at that inch. And then from 40, it will start at that 40 to the value less than 55. And then from 55 to that's how it is. And then at the end, we said 70 to infinity. That means that if you put 70 to 71, because the right is closed, it will stop exactly at 71. That's why we put infinity so that it will be infinity. Any value above 70, even if it's infinity, it should be included. And then we write our labels, and our labels will synchronize with the cut or the break we have specified area. So this is the cut function from here to here. So by default, this right argument is there, and by default it is true. So we don't have to specify it is true. Unless if we want to use the other way around, well, then we can say the right is equals to false, and then we have to specify the beginning value and then the ending value. So we can say, for example, 1. If we put 1 here, then it starts exactly from, so it will stop here exactly at 40 to anything less than 1. Then it will stop here exactly at 55, then exactly at 70, then exactly at 70, and it has infinity. So that means we have to specify the ending value. If the last observation we have is 100, then we need to put 100 here because that is where it is stopping, because it is open here. Then also we are creating a new variable called BMI category. So we are creating 2 variables in the same cut function with the same mutate function, and we are writing. So we create this variable BMI category, and we are using the same cut function, and we are using the default argument of right is equals to true. And at the end, we close our parentheses and we run everything. And then we see, we select the group, which is this edge group. So we have the edge group here. And if we select the BMI category, we'll also have it BMI category, just as we created it here. So that's how we create a new variable. This is very, very common in R. It's something that we need to learn, especially in data analysis. For example, um, if you're a data manager, you always advise people collecting data to collect, for example, variables like age in continuous form. Because if you have it in continuous form, you'll be able to convert it to a categorical variable, which age group. And then if you are doing further analysis like regression, you can use it in linear regression, you can use logistic regression. So you have more information if you collect it in continuous form. But if you, at the beginning, you just collect age group, then you have to mix everything in such a way that you cannot convert a categorical variable back into a continuous variable. It's not feasible because you have created age group. Maybe 100 people might have the same age group. So we have like lots and lots of information. Just like the BMI. So instead of accentuation, BMI is better to collect the weight and height, knowing that you can easily calculate the BMI during the analysis. So this is the mutate function with the if else. I want to skip this one because it's already on the time. This is a summarize function. We use the summarize function together with the group by function. The group by function will only use it for variables with logical labels. For example, variables that have labels that can be subcategorized in their labels, like gender, we have males and females, we have tribe, we have education, we have color of your skin, all those variables. We have like things a lot of variables that have labels and they are discrete, so you cannot have more than the specified levels. So that's why the objects you put, the variable you put inside the levels here, it cannot be continuous because we know continuous, it doesn't have specified levels. You cannot categorize. It can be character if that character is have some limited category, but the best thing is a factor because we know factor is something that is categorized already. So even though that this treatment group, I don't think it's a factor, but we can put it here because it's a character and then it has a certain number of levels on it categorized. So if you group by, so the output will be based on this. And then you summarize everything. So what you get at the end is because summarize, we take everything and summarize into 1, 2, 3 output. So the output will be based on this, and then these 3 variables that we have created. We know about mean, the median, and the mean, how to calculate means, and then round them into a single decimal place. But what about this n? So this n is taking everything. It's just like n, the n for samples. So it's taking n samples. So it's like taking the whole sample of everything. So if you run this one, you see that we have the treatment groups, which is group A and B. So everything is based on that because we are grouping by everything. Everything is grouped by that one. And then the number of patients in each treatment group, because we said N, so we are taking all the patients and their group. So you have 92 in drug A and 118 on drug B and 19 placebo. And then we are calculating their mean systolic blood pressure and their mean BMI. This is what we calculated, right? So we have the result for mean systolic and mean BMI. So we can do the same for other variables like sex. And then we can group by more than one variables. We have treatment group and sex. Just like we are cross-tabulating this one, just like cross-tabulation, right? Because you have treatment group and then you have the sex. So you can easily do your um, simple test for association. So let me show you this cross tabulation. We have packages, a lot of packages for cross tabulation. I just took this one, Tably. Um, it's also in the genital package. So what's OBP control? Don't have this one. It's saying that we don't have this column in the data set. So how do we check the names? We check the names of the columns in the data set, the variables. Oh yeah, I don't have it. I don't have it. Oh, maybe I created it somewhere else. Okay, let me just. Oh, I don't have it. Just a minute. Okay, yeah, I created it here. Maybe control. So that this is not actually very, but then if you look at that, we are cross-tabulating everything. You're getting the control and not non-control. So this is the name of the variable. This is not aesthetically looking nice. We have to control and not control. Then we have the end, that's number of observations. Then we have the percentage, and then we have the valid percentage. That's the one that is rounded up. So this is one of the way to cross tabulation. We have other functions like cross tab or cross table, or we can use the GT summary. The GT summary is much better looking, but even this one you can modify it so that it will look a bit better. But then we usually use the GT summary to do the cross tabulation. I'm just going to show you. I'll skip this visualization, updating our visualization. I'll go to the GT summary because, okay, basic statistical test. This is very important because the main aim of doing statistical analysis is to find association, find trends, find predictors, do all these things because if a clinician send you his data, you need to know whether there is an association between um, between smoking and lung cancer. How do you prove that association? You need to do some tests for association. So for the test of association, you have a lot of tests of association, but let's look at the basic test for association. And then there are a lot of statistical assumptions before you do test of association. So let's not um, look much about that. But let's talk about these two. We have the chi-square test and then we have the t-test. T-test is for continuous variable and it's comparing the mean difference of two variables, right? Mean difference. So mean difference of a continuous variable, mean difference. So we have different type of teachers. We have the independent teachers. So we have the dependent, you have paired, you have unpaired. So a lot of different type of statistical text. So this thing is so much complex. So it's not enough just to do a t-test, but then you need to know the type of t-test you are doing. But we cannot talk about that now. Just to show you how to calculate, how to do a t-test. For a t-test, you write this code chunk with to do a t-test, just write t dot test. It's a base R function. You don't need any package to do it. And then you write this like the equation, just like equation, right? So it has to be continuous variable, so it has to start with continuous variable because we said it's mean difference. So we put the continuous variable here, systolic blood pressure, and then this one is just its classifier, and then we put this tilde. So it will take for male and female because this standard has two factor male and female, and then bracket will write sorry comma then the name of the data set. So this will calculate the mean difference of systolic blood pressure between males and female, and it give us our p value. That's the most important thing, to get the p value to know whether it is a scale different or not. A p value that will also help us decide whether we are going with a null hypothesis or the alternate hypothesis. So we said this is Walsh two sample t-test. So we have one sample, we have paired, you have two samples. So we are doing this two sample. Even the two sample, we don't know the direction of the sample. There are a lot of ways to do that, but that would be something different. Statistics is very broad. So it gives us the t-test value, the degree of freedom, and then the p-value. So here we are just looking at the p-value, right? The p-value is 0.5. So it depends on how you structure your hypothesis, whether or your alternate set, the null which is the no association, saying that there's no association between this and it. And then the alternate is that there is association. So you decide which of the associations you are taking. And then you see here is supporting the mean for females. So this is the mean for females, and then this is the mean for males. So this is how it is written teachers. But then I want to show us this is also for chi-square test, just chi-square dot test, and then we table the result to get it in a structured way. So we have chi-square, we have the p-value. You remember we have similar to chi-square, we have p-share test. That's the expected value in the observations is less than 5. You use p-share test. So just write p-share the test. It will give us the p-share test. And then, yeah, the GT summary. So the GT summary packet, it's used to create a publication-ready tables. We can modify them as much as possible and then save them without needing to mix if you are using some RMD or QMD. Just save them directly in Word document or PDF or PPT, any format you want. So inside the GT summary, we have a lot of functions. We have this TBL summary for creating normal table. If you want to stratify your table by maybe 2 or 3 factors, you can use it using the strata, or you can use TBL regression if you want to create a regression table. A lot. It's a very, very versatile function, but then very useful. Let me show you how it creates the tables here. So it usually takes time, and there are a lot of things you can modify inside this TBL summary. So this is how it is. This is the name of the data set. Then we pipe everything into this function GT summary and TBL underscore summary. So we are saying by, so we are grouping everything by this statement group, and then we are including these variables. So only these variables will be included. So just like we are selecting, this includes similar to select. So we are selecting this, but this one is for the TBL summary. If we are, I'm not going to use this include, then from here, from this first piping, I'll filter, I'll pipe everything into select function, and then I don't have to include this thing. Then other things to include other arguments. It has a lot of arguments. Other arguments we have, we can put the levels. So this is like equals to. Then apart from levels, also you can put the type. You can put the statistics. A lot of things you can put the missing. So it's usually if you are writing, it's a long chunk of code that you can write at the same time, and then you get a table like this. You can modify it to better than this. But then the good thing is this thing you can export it directly into your. You can modify it in such a way that you're not able to go back to Microsoft Word to edit it. You can add your p-values that directly calculate your test of association if you are doing chi-square, if you are doing p-share test, if you are doing t-test, if you are doing Whitney, if you are doing Wilcoxon, whichever test you can do it directly inside this table that and then get your result and then export it, put it in your manuscript or your thesis or anything you are doing. So that's why writing this GT summary code is very, very long. Sometimes it can be a long from this place out to this place or even longer than that. So I will stop here and then maybe I will share the presentation so that we can go through one maybe another time. If we have time, we can discuss further. Thank you. And now back to the moderator.
Thank you very much, Dr. Hassan, for this wonderful session. Thank you for taking us through. Also, thank you for honoring our invitation. Thanks also to all who joined. I have shared the recordings for yesterday. I'm going to extract the recordings of today and share so you can still go through all the session and get a grasp of what has been taught so far. We still come back to you, Dr. Hassan. Maybe subsequently you're going to take us on some other aspect, or maybe with the continuation of this, because this is just like an eye-opener session. So we'll still come back definitely. Any question or comment? So I'm urging all of us, especially if you're just beginning to learn R, please try to get a laptop, because there was a time some of us were contacting me, they don't have laptop. Make it a budget. R, we've talked about the importance of R. Nowadays, the direction is towards this open software, not really point and click like SPSS, Stata and all that. So please try and get laptop and practice. By the time you start practice, going through all these sessions, with time, all this key record will be a walkover for all of us and for everybody. So please continue to practice. Maybe assign some time, even if it is 1 hour, 30 minutes, just practice. Get any data set, practice, or you can create your own data set and just practice. Like I said, in our platform, if you run into issues in terms of coding or any challenge that you encounter during your practice, you can just drop maybe the error or whatever, just drop it in the chat. We'll try to help. And also thanks to Usman. Thank you for your help in terms of getting our facilitator and also trying to mobilize some people. Thank you very much. Is Usman here?
Thank you, sir.
Okay.
Thank you, sir.
All right. Any other person with question, comment?
Sir, it's just a thank you note to the facilitator. Thank you so much. It is a wonderful today's webinar. Thank you so much, and we look forward to having you even very soon. Thank you so much.
Sure. Like I said, we'll still come back to Dr. Hassan for some sessions again. Any other person? Shina, any question, comment?
Just an appreciation to our facilitator, to Ari entirely, for organizing this for us. It's really helpful, and to our facilitator for taking his time and doing it in a way we understand. Thank you very much.
All right. We'll continue to practice. Like I said, I will share the recordings. Please go through practice. And we'll communicate when we're going to have another session. Thank you very much, Dr. Hassan, for these 2 days of taking us through in terms of an introduction. Like we said, we'll be happy to have you in another session again. And like I said, since you're in Kano, definitely we'll pay a courtesy visit to your office for sure.
Yeah,
go
yeah,
to
always welcome.
Kano Independent Center for Research Trust. For sure,
Yeah,
you see us.
yeah, always welcome. We are very happy to help you guys. We are always open for collaborations. KRCT is a very friendly place and is here to serve the people in Nigeria. So everybody is welcome to KRCT.
Yeah. Also, for those maybe new here, Unijust R User is sponsored by R Consortium, and for this year, usually last year we've been doing some session, and also after the session, sometimes we do give like a token in terms of monetary terms. We give like a token. But this year, we're yet to receive funding from our consortium. But once we get that, even our facilitator too, we will reach out to him, and also for those that join those sessions, we'll try to see, like we usually do, we give some token. But for now, we haven't received any fund from our consortium. All right. Thanks everyone for joining, and have a wonderful night rest.
Okay, thank you. Good night. Bye bye.
Thank you, sir.
Thank you. Good night.
Thank you.